Okay, welcome everyone. Let's look at the third major biomolecule in the body. We have already covered proteins. We have already covered carbohydrates. Now it's time to look at lipids, and then we'll also cover the nucleic acids. These are very important macromolecules in our bodies. Okay, so what are we going to look at? We are going to see what are these lipids made up of. Therefore, what are the things that actually make them have the properties that they have? What we are emphasizing here is that what the lipids consist of is actually what determines the properties of the lipids. Okay, and then we also see the properties that lipids have are the ones that determine their functions. So that is how that's how the conversation is going to flow in this lesson. So biomolecules, these are important molecules in the body that carry out different functions. Lipids are having low solubility. Lipids have low solubility in water. Okay, and we will explain why. Okay, we'll explain why. Remember the statement that like dissolves in like. So if lipids have low solubility in water, it means that lipids are not really like water molecules. So there's a difference in terms of their structure. And therefore, what this hints on is that lipids have a high solubility in non-polar solvents. Okay, so that means that at least from that statement, we are able to know that lipids are not really very, very polar. Okay, they are not very polar, so they are non-polar, and that's why they dissolve in non-polar solvents. Okay, so they are largely having a chain of hydrogen or hydrocarbons. Okay, a long chain of hydrocarbons. That's what largely makes up the lipids. Okay, so this long chain of hydrocarbons is actually what contributes to the non-polar nature of these lipids. Okay, so with all the other biomolecules that we have talked about, they have what we call functional groups. These are chemical groups that actually influence the chemical properties of those molecules. Okay, but we are saying that with the lipids, they don't have a common functional group. Okay, and they don't have generally the same structure formula. So that means that lipids are actually diverse. We have very many types of lipids, depending on whether they are simple molecules or simple compounds, or whether they are complex, very long, with the other compounds being added to them. So there are actually many. And here we have indicated sources of lipids. They can be plant-based sources, or they can be animal-based sources of lipids. Okay, so like all the other micromolecules, lipids contain carbon, hydrogen, and oxygen. Okay, what actually defines is the proportion of these elements. Okay, so oxygen is always smaller compared to hydrogen and carbon. Okay, and that actually also influences the amount of energy that is actually derived from burning lipids. Okay, so what we are stating here is that natural fats and oils are compounds of glycerol and fatty acids. So what we are saying is that whether you're talking about fats or oils, you're talking about a compound that is made up of glycerol and puric fatty acids. We shall see that later on. Okay, we'll notice that the fats are actually solids at room temperature, and then the oils are liquids at room temperature. And we'll see that the oils come from plant, and then the fats come from animal sources. We are also noting that lipids have high energy value in comparison with the other major macromolecules. What does this really imply? Is that when you burn the same quantity of either protein and carbohydrates and then also lipids, you'll get more energy from burning lipids than burning any of the other two that I have just mentioned. And this, you'll realize later on that actually it is because of the hydrogen, the number of hydrogen atoms that we have in lipids. Okay, so they are very, very important for a number of functions. Remember, I say they are very diverse, meaning that there are very many fatty acids. Is fatty acids, or you can say lipids, very many types of lipids, and therefore they perform very diverse functions. Okay, the formation of these fats, we have said, is when you have a glycerol combining with fatty acids to form the lipids. Okay, that combination is actually called esterification. It involves formation of what we call ester bonds. So you have glycerol, which is this compound here, combining with the three fatty acids. This is 1, 2, 3. Okay, that combination is what we call condensation. When a compound is building up to form a larger molecule, which is this here and here, that is what we call condensation. So usually water is lost in that reaction. And then when you're breaking this complex compound into what makes it up into its constituents, then that process is what we call hydrolysis, and it involves addition of water. So when you are combining the two, the process is esterification, because you are having ester bonds being formed between glycerol and the fatty acids. Okay, and of course, water is usually removed.